So I'm going to write my answer as well. Proton is a subatomic particle of an atom which has a positive charge, or which carries a positive charge. Right? Okay. The next one is a subatomic particle. A subatomic particle are the components, right, that make up an atom, or the building blocks of an atom. Building blocks of an atom. That is electrons, protons, and neutrons. If you just tell me the building blocks of an atom, I'll give you a mark for that, because I only needed one strong point. Okay? Okay, an element. I need 2 answers for this one. And for this one, I want you guys to help me answer. So in the chat, tell me what an element is. I think I should ask you guys to answer verbally, maybe. Do you think that will help with the time? I think it will. Okay, so anyone who has the answer for element, answer me verbally. So you can unmute yourself and answer me.
Ma'am, I said an atom that has the same amount of protons.
Oh, I can't hear you. You're a little bit soft. Say that again.
I said an atom that has the same amount of protons.
Okay. So you're saying that an element is an atom that has the same amount of protons. Okay, you're close. An element is made up of one type of atom, right? And you can add your point there that says it has the same amount of protons. Well done. Anything else? Does anyone else have an answer for this? Okay. Another thing about an element, it is a pure substance, right? When something is a pure substance, first of all, it is made up of one type of material, okay? And secondly, it has chemical bonds that bond the atoms together. So that basically means that if you were to try to physically separate it by means of evaporation or boiling, it's not gonna separate. You need to use electrical systems to separate it, such as, do you remember when we done that experiment with electrolysis, right? Where we broke down copper chloride. So it is a pure substance. It has, it is chemically bonded. Here we go. That will be enough for that answer. Okay, an atom. This one you guys can answer me because it's really easy. I want Sarah to help me answer this. Sarah, you can answer me verbally. Yes.
An atom is made up of tiny particles.
Well done. Made up of, instead of tiny particles, let's use the word subatomic particles.
Okay.
Okay, and what else can you tell me about an atom with regards to its size?
Ma'am, it's the smallest ordinary matter.
Excellent. It is the smallest particle of matter on Earth. Well done, Quentin. Okay, next one, electron. Let's hear it from Jensen. Jensen, it's only for 1 mark, so just give me a 1 mark answer. Hello, Jensen. Okay, I'm going to ask Chloe. Chloe, can you tell us what an electron is? Okay, can anyone tell me what the definition of an electron is? Okay, I think we are. Oh, Jensen got shut out. Just adding him in again. Okay, so the definition of an electron is a subatomic particle within an atom that has a negative charge, right? So a proton is positively charged and an electron is negatively charged. Okay, a molecule is a structure. Wow, Ethan said a molecule is the smallest particle in a chemical element or compound of that element or compound. Well done. Well done, Ethan. That's perfect. Okay, so I'm just copying and pasting Ethan's answer here. Ethan says, a molecule is the smallest particle in a chemical element or a compound mixture. Well done. Right. So if you gave me that answer, I'm going to give you 1 mark. All right. And if you can tell me more about it, it is made up of 2 or more atoms bonded together. All right. So those are the 2 answers I'm looking for there. Okay, a pure substance. If you know the answer, feel free to pop it in the chat. If you guys think you have anything in addition to my answers, you're welcome to write it down, just like Ethan did. So a pure substance is a substance that cannot be broken down by physical means, right? There are chemical bonds between the atoms, right? So if you gave me those 2 answers, you already get 2 marks. I'm just giving you extra stuff you could have said. What else could you have said, guys, about a pure substance? Okay, so it can be an element or a compound, right? Those 2 are pure substances. A mixture, on the other hand, is not a pure substance. Okay, moving on. A decomposition reaction. What is a decomposition reaction? Ethan says, a decomposition reaction is a type of chemical reaction in which a single compound is broken. Well done, Ethan. Now, these are really awesome answers. Well done. So I like this answer because it's telling me that it's a chemical reaction, and it's telling me that we're breaking down compounds in this reaction. So you can't break down an element, and you can't break down a mixture through chemical means, but you can break down a compound through chemical means. And I'm going to add to this using heat or electrical energy. All right? That part is optional. You don't have to write that down. And here Muawiyah is entering our chat. Okay, let's move on. So guys, I think those are just basic definitions to, help you guys focus on the summary of this chapter that we done for this term. Moving on to question 2. You needed to give me differences between elements and compounds. All right. So I gave you, I helped you and I guided you along. First of all, you needed to give me the definition of an element and a compound. Right. So definition of an element. If you know the answer, pop it into the chat. An element is made up of one kind of atom. All right. A compound is made up of more than one kind of atom bonded together. Made up of more than one kind of atom bonded together. So, an example of a compound, and Sarah says it is made up of one type of atom and is a pure substance. Well done. Yeah, and is a pure substance. Guys, you can answer. I see you guys are answering me privately. I want everyone to see your answers because they are really, really good. So people can benefit from those answers. So just change your settings there. Okay, a compound. Is a compound a pure substance as well? Yes or no? Yes, a compound is a pure substance. Okay, what isn't a pure substance is a mixture, because a mixture is made up of a whole lot of elements and compounds put together. But a compound is a pure substance because the only way you can break down a compound is through chemical means. So you have to take electricity and let it break down a compound, or you need to use heat. Okay, so it can't just be broken down through physical means. Okay, an example of an element, and I want all of you guys to try and answer this. What is an example of an element, and what is an example of a compound? Oops. Okay, I'm just going to give elements on the top of my head. Hydrogen is an element. Oxygen is an element. Helium, gold, copper, so many. Muawiyah saying, I don't know. But Muawiyah, we learned 20 elements from the periodic table, so you should be knowing that. And an example of a compound, we have water, we have salt. Remember, water is H2O. Salt is written like NaCl, sodium and chlorine, right? What else is a compound? Carbon dioxide that we breathe in, that we breathe out rather, dioxide. etc. Okay, moving on. And guys, just let me know if I'm going too fast. I know that you guys are taking it down as well, so if I'm going too fast, just let me know. All right, the next thing, you needed to give me the differences between pure and impure substances, right? So I've given myself a little roadmap here. The first thing you need to tell me is what is the definition of a pure substance and what is the definition of an impure substance. So first of all, the definition of a pure substance is that it is made up of elements and compounds are pure substances. Yes, Sarah, that's 100%. Oops, my spelling is really off today. Okay, another thing about a pure substance. Okay, so let's look at the definition of an impure substance. It is made up of a combination of elements and compounds. Right? So let's look at an example of a mixture. An example would be air. Right? If we look at the atmosphere around us, it's a mixture because it's made up of many elements and many compounds, right? It's made up of water, which is a compound. It's made up of carbon dioxide, which is a compound. It's made up of nitrogen and oxygen and hydrogen. They all are elements, right? So can you see how that's a mixture? But if we look at water on its own, water is a compound because it's only made up of 2 atoms bonded together, all right? And water is also a pure substance. Okay, so the definition would be a substance made up of combination of elements and compounds. Okay, the type of bonds that exist between pure substances, are they physical or are they chemical bonds? Let me know in the chat. Are they physical or are they chemical bonds? Sarah, we're going to add your answer in the next one, all right? So the bonds here are chemical in a pure substance, and the bonds in an impure substance are physical, all right? Meaning that you can separate them with your hands physically or with another physical method like boiling, all right? Because they're not chemically bonded together, okay? They're not like stuck to each other. Okay, separation method for a pure substance. And now we add Sarah's answer here. Cannot be broken down by physical means. All right. And we need to break it down by using electricity or heat. All right, by using electricity or heat. The separation method for impure substances, on the other hand, it can be broken down by physical methods, right? Can be broken down physically. Example of a physical method is by evaporating it, by boiling, by physically sorting it out with our hands, right? We'll just call it sorting. By filtering. Desalination. Desalination is when they separate, when they purify seawater and they separate the water and the salt. Okay. Okay, guys, I hope this makes sense, and I will be giving you the answers on Google Classroom so that you guys can make sure that you have these answers if we were to write a test. Or I'm going to give you assessment dates by Monday. All right, so you know, every time you'll write a test or any assignments that you have for both English and social science. Okay, the next thing we're doing is question 3. It says give the ratios of the following compounds. You can write it as a ratio or in words. Now guys, what I want here is that I'm going to give you a chemical formula. Remember that every single thing on earth, every mixture, every compound, every element has a chemical formula. If I ask you to write the chemical formula of hydrogen, it's just H, capital H, right? If I ask you to write the chemical formula for water, it's H2O, right? But we also have other compounds and elements. It's not just water and hydrogen, right? So I'm asking you to put it in a ratio or in words. So an example here was H2O. You just need to tell me how many atoms of each element there is in the compound. So in H2O, there are 2 hydrogen atoms. Can you see, because there's a 2 next to the H? And there's 1 oxygen atom because there's no number next to the 1, next to the oxygen. All right? Okay, help me answer this one here. So we have a compound called sulfuric acid. Sulfuric acid is extremely dangerous. You know, people throw acid on victims, right? And it basically burns their skin. So it's a very dangerous thing. And it's actually used as a weapon, right, of torture. So sulfuric acid is made up of, sorry guys for the disturbance behind, is made up of H2SO4. All right, so it's made up of hydrogen, sulfur, and oxygen. I want you guys to tell me how many hydrogens are there, how many sulfur is there, and how many oxygen atoms are there in this compound. And you can give it to me in a ratio format. A ratio format is like something like this, right? Or you can say there are 2 hydrogen, 5 sulfur, and 6 oxygen, for example. And I want you to answer me in the chat, please. Quentin, this is for A. Okay, Sarah says 1 is to 2 is to 4. Your order is right, Sarah, but something is wrong there. You need to switch the 1 and the 2. So we have 2 hydrogen is to 1 sulfur is to 4 oxygen. Do you guys see how that works together? I'm just going to try to draw this for you to help you correlate. So it's 2 hydrogen there, 1 sulfur, and 4 oxygen. I don't know if that's making it more complicated, but yeah. Yes, well done, Chloe. So it shouldn't be difficult, guys. And if you want to write it in words, which you absolutely can, there are 2 hydrogen atoms, 1 sulfur, and 4 oxygen atoms. Right? That's all you needed to say. Okay, help me answer B. I know Quentin was attempting to answer this one. Quentin, let's help. By the way, what is Ca? Ca is calcium. C on its own is carbon, and O is oxygen. All right? So remember, if there's no number next to the symbol, that means there's only one element of that. Okay, so Quentin says there's 1 calcium and there is 3 CO. Quentin, break down C and break down O. Remember, C and O are different elements. So we have 1 calcium atom. Oops. Atom. We have 1 carbon atom. You girls are missing out on carbon. You're giving me 1 and 3, but you're not realizing that, and you see that carbon over here is also a separate element. So there are 3 elements in this compound: calcium, carbon, and oxygen. So there's 1 carbon and there are 3 oxygen atoms. Okay, Marcus, well done, Marcus. So if you have to put it in a ratio, it's going to be 1:1:3. Okay, next one. We have a compound called calcium chloride, right? Ca stands for calcium. Cl stands for chlorine, okay? And can you guys see how Cl has a 2 there? It has a 2 because it's a diatomic element. And a diatomic element is an element that exists as 2 atoms in nature. Do you guys remember how we learned have no fear of ice cold fear? The cold in that sentence stands for chlorine, right? So give me the ratio for this. Here we have 1 calcium atom and 2 chlorine atoms. Remember that in a symbol, if I have a capital letter and then I have a small letter or lowercase next to it, that's just one symbol that stands for calcium, right? It doesn't mean that the A is a separate element. Okay, Marcus says 1:1:2. Marcus dropped the 1. It's just 1:2. And how does this make sense? Because there's 1 calcium and there are 2 chlorine. Guys, I hope this is making sense so far. Let's move on to the next one. Ethanol is basically alcohol, right? And that is the chemical formula for the compound of alcohol. And we have, wow, we have quite a few elements here. So we have C, H, O, and H again. So in a ratio, oh, I see Chloe has already asked me. And Chloe, you are absolutely correct. Let me show you guys why Chloe is correct. So we have 1 carbon. Sorry, not 1 carbon. We have 2 carbon atoms. We have 6 hydrogen atoms. We have 1 oxygen atom. And then we have again 1 hydrogen atom. Right? And if we had to put it in a ratio, we do so like Chloe has done. 2:6:1:1. Does everyone understand so far what is happening? Because I'm only hearing responses from Marcus, Quentin, Sarah, and Chloe. So I'm worried that the rest of you are lost. Okay, so I'm moving on. And if you guys need any clarity on the previous questions, just let me know. Okay, so question 4, and this is a nice question. It's really easy. How many atoms make up this molecule? So this is one molecule of a compound, okay? And I want you guys to count for me, like physically count. How many atoms are in this molecule? I'll actually count with you. Counting again. Yes, 24. Well done. Okay, so there are 24 atoms in this molecule, right? Now, question 2 is different. How many different type of atoms make up this molecule? How many different types of atoms make up this molecule? Well done, Chloe. So there are only 3 different types of atoms that make up this molecule. All right, why? Because the red, can you see the red there? That's one element. The gray is another element, and the white is another element. So all those 3 elements are different types of elements. Okay, they could be oxygen or hydrogen or nitrogen, doesn't matter. What holds the atoms together in this molecule? What holds the atoms together in this molecule? Is it a physical or chemical bond? I'm interested to see what you guys have to say for this. Remember, it's a molecule of a compound, and a compound is a pure substance. So is it a chemical bond or is it a physical bond? Chemical bond. Good work. Okay, and guys, I've added one more question in the 3 minutes that we have remaining. The question is going to come into your exam papers as well. So I just thought, why not edit in today's lesson? So in your papers, I'm going to ask you to draw certain atoms, right? So I'm going to tell you, refer to the periodic table and draw the atom of beryllium. So you're going to go to your periodic table within your paper. It's going to look like this. You're going to look for beryllium. Beryllium is over here, and I'm going to zoom in so you can see it properly. It's right over here, and it is the 4th element of the periodic table, meaning that it has 4 protons and it has 4 electrons. So with that knowledge, I know that I can draw this element very easily. And I want you guys to draw it in your workbooks, okay, or on a piece of paper. We are doing beryllium today. So we know that the atomic number is 4. The atomic number is a small number in the periodic table. It tells me how many protons and how many electrons there are. In beryllium's case, there are 4 protons and 4 electrons. So I'm simply going to move my little already drawn protons into the nucleus. The nucleus is the middle of an atom, right? The center. Just arranging it. Okay. And I know how many neutrons there are. You guys don't have to know neutrons for the paper, okay? So let's ignore let's ignore the neutrons, which are over here. Anyway, so there are 4 electrons, so we just place the electrons on the outer orbitals, and this is how you're going to draw it for me in your papers.